So I'm going to report experimental results from a document collection. Basically, the document collection is a set of web pages taken from DMOZ categorized web documents. Basically, this collection has category assigned by human editors for each web page. So here we took only around 300k documents, and it created about more than 1 million unique terms. And the documents belong to one of three topics: computer or science or sports. Okay, so and the computers had almost 115k documents, and it's kind of similar across all these three topics. And also, after performing the SVD, for the canonical the semantic space, we kept only 30 dimensions. Okay, so the first step is to create the set of canonical queries, and it created this procedure created 2.6 million seed queries when the frequency threshold was set to 500, and it created almost 1 million canonical queries, where the length of the queries are listed in the table. Also, you should note that the average canonical query length is 3.7, which is almost 4, right? So you can see there are a lot of queries with 3 or 4 terms when compared to 6 terms or 2 terms. Okay, the first question is how many unique documents. So you have the whole documents with 300k documents, right? And how many documents the canonical queries can reach? When you issue the canonical query as a query, do they reach all the documents in the collection? That's the first question. So if you use the Tfi-idf based simple retrieval scheme, you see that in the x-axis we plot the number of documents retrieved for each canonical query. So in the x-axis, so we compare the performance between 100 documents retrieved, 200 documents retrieved, and 500 documents retrieved. So if you retrieve 500 documents per canonical query, you can reach almost more than 99.4% of the documents in the collection. Okay, the next question is, okay, some documents are not at all reachable, even if you retrieve 500 documents per canonical query, and why it is that? If you look at the unreachable documents and their length, basically number of terms in that documents, it's low compared to the general collection. So the average document length, number of terms in the whole collection is 360, but the average document length of unreachable documents, the documents which are not reachable by canonical queries, is just 35. So that explains why some of the documents are not at all reachable, because they don't have many terms to even be a significant document. Okay, second question. So the other aspect is the retrieval performance. So here, instead of submitting your original user query, you are going to submit something else, right? And does it fetch? What happens to the relevant pages that you get? Here, in the x-axis, we show. Okay, so using the original query, we retrieve 20 documents. 20 documents. We treat them as the relevant documents. Okay. Then using the canonical query, we retrieve 100, 200, 300, 400, and 500 documents, and find how many documents overlap in the top 20. Okay. So if you look at it, if you retrieve the very first column where it indicates the x-axis where it indicates 0, for 100, when you retrieve 100 documents, almost 15% of the queries don't have any match, 0 match in the top 20. But it decreases, 0 match decreases as you increase, you get more documents, you retrieve more documents for each canonical query. And if you look at the last column, or to the right, the end of the x-axis where it indicates 20, for 500 it retrieves almost 15%. It retrieves 20 of the top documents, which is very similar to what you get from your original user query. So you can see, if you retrieve more documents, you can get, it's very similar to what you get from using your original user query. Okay, the second aspect of this is the topic diversity. So we said when you construct this PD query set, we said the query should be from different topics, right? So here we have three categories of web pages. One is computer science and sports, right? So we measured what is the topic diversity in a PD query set constructed based by the algorithm, right? So in the x-axis we show the topic diversity based, it's a kind of a normalized measure we get from the DMOZ categories. So as it shows, around 85% of the PD query sets that are coming out of this algorithm have more than 50% of topic diversity. That explains different queries from different topics are put together in a single PD query set based on by the clustering algorithm. Okay, so I'm going to almost finish up now. Okay, so the PDS system, the summation of more than k queries can be used along with other tools we already saw, private web search, or even onion routing, so that you don't release your IP address to the search engine, etc. It can be used with those tools also. And the future work, for example, so we are saying we want to build all possible queries through these canonical queries generating algorithm. But how to do it efficiently? Currently for a collection of 300k documents, we have almost 1 million canonical queries, right? But for web search, it's a huge collection. It might increase the set of possible canonical queries to too large to maintain. So how do you generate all possible canonical queries efficiently? That's one aspect of this future work. And also improving retrieval performance. So you're going to replace your original query with a different query. Then how do you make sure that the transformed query will bring you what the original query will bring you? So you want to have a maximum overlap in that. So that's another aspect of this canonical query problem. The other thing is a sequential query. So the web search is also, the query log usually contains several sequentially edited queries. You search for something, then you edit it, right? You refine your query as you go along. So in that case, what happens? How the PDS system should work. It's again something for the future work. So if somebody takes a look at sequentially edited queries, can they figure out the actual queries even though they are using PDS system? So that's again something that we are working on. Okay, thanks. Any questions? Okay, then thank you.